Hello, this is Mr. Manley, and in this video I want to talk about the zeros of a function and the intermediate value theorem. Let's begin by talking about this word zeros. What does that mean? The reason that we use the word zeros is because if we are talking about a function, f of x equals, and then there's some expression in terms of x, we often talk about solving for x. So we could say solve for x. And how do we solve for x? We solve for x by setting the expression equal to 0 and then figuring out what value of x makes this expression come out to 0. That's why we call it the zeros. So notice that we say the zeros of a function, and that's going to be really synonymous with solving for x. Now, if you think about that, take it another step further and think about what this means. If I were to take a table of values for this function, where I have an input x, which gets input here, and then I have an output f of x, so maybe not here specifically, but input x, and then I'm going to have an output f of x. Well, that's the x value, and that's the y value. So when I do the zeros, when I find the zeros of a function, what I have done is I've said I want my output to be 0, that being f of x. So f of x will be 0 if we look at the table here. And then I'm going to solve. Remember, I'm going to solve and figure out what value of x will make that come out to 0. So whatever values I get go in here, that is going to be the x value when y equals 0. Now let's take that one step further. If I have the x value when y is equal to 0, and I look at that graphically, where is that going to be? That's going to be like somewhere here. Like if I had points like that, that point could be some x and then 0. And then this could point some other x and 0. And this point could be some other x, 0. So in a function, wherever y equals 0, I'm going to have an x-intercept. So now we have another thing that is synonymous, x-intercept. So these are all really work together, right? That we've got the zeros solving for x and the x-intercept. Those are all really just about synonymous, depending on, we're going to use different ones in different contexts, right? So these are the zeros of a function. Now talk about finding the zeros of a function. Let's look at a really basic example. So here is a function, and say I want to find the zeros for this function. So I would set the expression equal to 0, and then I would solve for x. How would I do that? In this case, I would be able to factor. So that would be minus 6 plus 1, and I'd get my zeros at x equals 6, negative 1. So I've got the zeros. I got the zeros from the factors. These are also going to be the x-intercept. And we found it by solving for x, by letting the y equal 0. Okay? So that's a simple case. Now let's take a really general case here. So I'm going to look at a function that is really just, I'm not going to define it specifically or anything. I'm just going to say that there's some function here. So there's some function, and let's say that that function is f of x. Now, we don't have the expression for that function, so we can't solve We can't solve anything here because we don't really know what we're dealing with. But I want to talk really generally here about the zeros, or the x-intercepts, as it were, of this function. If I were able to confirm a position of this point, and let's say that position is at some point A, which means that if I plug it into the function, I'm going to get f of a. So we're talking very generally here. We don't have specific numeric values. And then say I find another point here, and say I find that point, and that point is point B, and if I plug it into the function, I'm going to get f of b. What I want to say here is that if I can find 2 points like this, an A and a B, such that f of A is positive, which I'll say it like that f of A is greater than 0, and f of B, I did not want that to be positive, so let's back that up, reverse it. I want to say that f of A is less than 0, just to be consistent with my picture here. So that f of A there is going to have a negative value, right? Because it is below the x-axis. So I've got f of A is less than 0. F of B is greater than 0. So another way of saying it is that this is a negative value and this is a positive value. So if that is the case, if I've got this point A, f of A, and this point B, f of B, I can say if f of A is less than 0 and f of B is greater than 0, then there must be a 0 on the interval AB. All right, and that's just interval notation. This is interval notation to indicate between A and B. So somewhere between A and B, there must be a 0. There must be an x-intercept. This generalization of taking a function and looking at where does it move from positive to negative, and then making the logical, making that it logically follows that there must be an x-intercept there. This is called, it has a name, we are using the intermediate value theorem. Yes. So the intermediate value theorem says that if I can find a negative value, a negative y value, and I can find where a positive y value is, there has to be an x-intercept in between there. Because to go from negative to positive, we had to cross the x-intercept. Okay? So that is a little discussion of zeros, x-intercepts, solving, and how that all relates to the how it all can relate to the intermediate value theorem.